Okay, let me set up the timer. So, hello everyone. My name is Guoyan Li from Norwegian University of Science and Technology. My title today is Digital Twins for Marine Operations Safety. So this is a topic that is used as a use case in the RoboSAPIENS project. Oh, no. Yeah, now it works. Yeah. So the outline for today includes several parts. So I will start with a brief introduction about our department, which focus on ship operations, marine operations, then come to a concrete project showing our knowledge accumulation. Then I give some detailed introductions about some key technologies and enabling tools, and followed with some case studies and conclusion and future work at the end. So our NTU is contains 3 campus, Trondheim as a headquarter, and Gjøvik and Alesund as some new campus. And away from Alesund has special locations compared to the other 2 campus. So the special thing is that we have the campus that is closest to the industry. Here, the industry is related to the marine industry. And in the regions of Norway, especially showing in this picture, Ålesund is the industry areas that focus on fisheries and operations. And there are also many ship owners, ship yard, building ships there. And they contribute a lot to the entire Norway economies, and have more than 80,000 employees working in this area. So in this, from this context, our department aims to become a leading knowledge hub in marine operations and coastal infrastructure. So to this end, we have generated several key projects in Norwegian research councils. And our knowledge is accumulated from modeling, simulation at the beginning, virtual prototyping, towards digital twins, and further human-machine interaction that here is called remote control and autonomous. So here I will pick one of the key projects, the KPN, Digital Twin for Visual Life Surface, as an example, and show you how we generate a digital twin and how the twin can be supported to RoboSAPIENS project. This KPN project in full name is knowledge building project. In this project, we aim to develop open standardized digital twin platforms or infrastructure that focus on operation safety and life cycle services. And the project is, as I said at the beginning, is fully supported by the local industries from the Kongsberg, RKP, Sintef, and the DNV GL. So our goal is trying to develop the twin of the operation ship that can be reflect the behaviors of the ship in a digital manner. More in detail, we split it into 3 objectives. At the beginning, we should provide a standardized simulation platforms to digitalize this ship behaviors. So this is a fundamental which can provide communications between models so as to generate holistic simulation platforms. After that, we have the enabling tools, which serves as the middleware, and we have a few PhDs working in this part. So based on the simulation to provide some reasoning and intelligent tools to support high-level applications. That is our case studies. So before I dive into the digital twin, let me introduce our infrastructure. So this is called Gunner's ship, RV Gunner's ship. And this is a research ship that can be used for maneuvering test, for environment monitoring, and also support for some sea trials and operational studies. So this is open for the entire NTNU colleagues and for the research teams. In order to achieve or working towards digital twin, we first have mounted many sensors in the ship. So for example, here I show you the crane sensors, the wave radar, GPS, MRU, and engine sensors. So using the sensors, we can gather all the sensor information when the ship is in operation or in navigation. Then we can represent the ship behaviors in a digital way, and based on that to generate the twin. So when the data is collected by the local sensor, so you will see there is a Luke PC. How do I show the? Yeah, you see there is a Luke PC on the physical asset that can transfer the data through the 4G signal to the remote. So that is on the right side. So where we have the server, where we have the database, and where we have the digital twin. So that place will be later I will explain, to be serves as a remote control center that can monitor the ship behavior and even to do some remote operation in ideal situation, of course. So in this context for digital twin of ship operation, so we see this concept. So we have the IoT solutions to collect onboard sensor data so that we can use the sensor data to do some AI modeling. So here we can refer to physics-based modeling, use equations, use parameter identification method. These are classic. And also we can apply data-driven method to generate AI models, which can represent the ship dynamics. And then this twin ship models can be used for visualization, digital decision-making, and human-in-the-loop controls, which can provide some actions back to the real ship from onboard support, decision-making, to remote control. So now the concept we understand. Now we come to the first objective. How can we implement the digital simulation platforms? In terms of the system integration, data integration, and model fidelities, and the interoperabilities and the standard challenges, you can see from the figure, there are many subsystems inside this ship systems. From the engine, from the hull, from the thruster allocation problems, they are separate problems. And in real world, they are provided by different supplier providers, meaning that they can provide a user function, but it's hidden and they are running in different platforms. For example, some model from engine are running in Python, and some model from the power management is running in Java. So the question becomes, how can you put all the models into one and let it running in parallel in a holistic way? So these are some challenges we often encounter in these big systems. So that's why we proposed this open simulation platform, which can provide a standard way. We're taking this FMI called the functional markup interface, and to collect all the data in a standardized library, using C++ library. So to provide the services and even for applications by combining all the models together. So if you are interested, you can follow the link to see more details about the tool. So this picture shows the concept idea. With the fMRI, you can collect the sensor data from the thrusters, from the engines, and also you can combine with some other third-party tools. So all the informations can be exchanged or controlled, handled by the master algorithms so that the entire systems can be communicated, synchronized by the master algorithm. So this is the simulation platform. We'll take it. Based on that, we have the enabling tools that trying to provide some from the raw data to the perception levels of understanding the ship behaviors and provide some intermediate support to high-level applications. So we have 8 to 10 PhDs working in these categories, from data analysis to the performance optimizations to onboard support. So due to time limit, I just go through very quickly. For example, some PhD working on sensitivity analysis, try to model in the effect of the headings undergoes the environmental changes. And hybrid modeling, taking the mathematical model together with the real data from sensors, try to combine mathematical model with data-driven model to improve the performance of the dynamic models of the ship. And also we have the engine lab, and we can try to use data-driven method to provide tools for fault prognosis and diagnosis, especially used for predict the left lifetime of the marine components. And also we can, we are not placing buoys on the ocean. We can use the ship itself as a buoy. So the ships under the effect of the environment can have different motion behaviors. We can use the motion behaviors to inversely estimate the ocean weathers. So this is some ideas, data-driven ideas, to use this big ship buoy to predict the sea state. And also some method for neural network-based models, tools for force allocation, convert the optimization problems into nonlinear problems using neural network. And also some tools for path following and for onboard support. So due to time limit, I skip it. So here I just use the rest a few minutes to show you some case study. The first one is the docking experiment. So we take 11 ship docking tests in 2023 in Yellowstone Harbor. And we trying to use the data to train the ship twin models. And we get some results. And that is not ideal, but close to the real situations. So meaning that we can use our twin, that blue shadow, right, in the simulation, to predict the ship behavior. So this is the verification of the fidelity of our ship model. So this is our first test. So the second test is for remote monitoring. So we have the model that is trustable now. So how can we use of these twin models? So we have this remote operation center. So some colleagues has visited there. And when we do operations in the ocean, in the remote operation center, people can use these technologies to see what has happened, like this one. So we have developed the tools that in the remote operation centers, we can monitor the behaviors using this tool. Of course, there are some limitations. We don't know what is loading and what is how heavy is the loading. And also the pitch, your behaviors are not well reflected in the video. But the idea, the concept is trying to use the twin system to do remote monitoring. Yeah. And the last scenario is case study is what if scenario. So for marine operation, the difficulty is we don't know how difficult it is or how dangerous it is in some extreme sea conditions. So using these tools, we can simulate the behaviors and find the proper operation window to guarantee the safety. For example, from this window, from this video by the company we are collaborate with. So this is our remote operation center. The ship is on sailing and in operation from Turnham to Ålesund, from one campus to another one. And the right side video is the real one. And this is the digital twin. So OSA is visualization companies and professional for that. So you will see from their platform, we can see the behavior is almost identical. And in these platforms, we can do some bird viewing. You can fly anywhere as you want, and to see the behavior of the ship motion. The highlight of this tool is we can do what if operation. So you see if we select the virtual ship, if we do some ship crane operation under the sea waves. So you will say some operation is safe, but when the increase of the sea state, the ship may drift away, which means it's dangerous if the sea state is in this level. So we can do this simulation in parallel and provide a different constraint. For example, we add another twin. So by use of these twin platforms, so we can identify in which conditions this operation is safe, and we can guarantee the marine safeties. So I can't drag and play. Yeah, that's the idea. So when the sea state changes, you will see one of the ship will drive away and another we can keep since they have different load conditions. Okay, so the last slide. Yeah, from these presentations, I show you our department, the knowledge accumulations to this anti-gunner ship twin project. So this is the foundations when we join the RoboSAPIEN project. So now we are more focused on model adaptations and trustworthiness, and based on the knowledge we accumulated, so we can provide this use case to the project. Okay, thanks for your attention.